Good evening to all. Today we have assembled for the memorial lecture of Sri B.G. Rudrappa and Dr. D.L. Subramaniam. And today's topic is Advent of Electric Vehicles and its role in future. I glad to welcome Sri Rajashekhar, Kekanaje for this endowment lecture. And I welcome the audience present here in this venue, as well as who are watching online in the YouTube. As per our custom, first I will introduce the endowment, this thing. Today we are having two endowments clubbed together. One is Sri B.G. Rudrappa, who was the first chairman of the Karnataka Electricity Board. Beskam. I remember he was a very technical savvy person, chairman. And during his period only, wireless was introduced in the Karnataka Electricity Board for the one is communication purpose. At that time, I was working in Kionics. I was part of that project. And he was also served as the former director of the Karnataka Power Corporation Limited. And he was the distinguished power engineer and an active proponent of promoting renewable energy. He was the former secretary, Central Electricity Authority, and a member of the advisory committee of Karnataka Electricity Regulatory Committee. He was generally interested in varied subjects, both technical and of general interest. He passed away on 5th August 2016. This endowment has been instituted by Sri V.S. Rao in the year 2016. And another endowment is Dr. D.L. Subramaniam Memorial Endowment Lecture, born on 17th July 1921, and obtained his MSc Physics from Central College, Bangalore University, and he passed the BSc with a gold medal, and he did his PhD in electrical engineering with the specialization of electronics and acoustics from Massachusetts Institute of Technology, USA. He was the assistant in research department of communication and science and teaching fellow in electrical engineering at the University of Michigan, deputy director of Central Electronics Engineering Research Institute, BITS Pilani, Rajasthan, and director of R&D at Bush India, Bombay. Director and Chief Executive, Sarabhai Electronic Research Center, Ahmedabad. He was an active tennis player until 80 years of age, an amateur photographer also. This endowment has been instituted by DLS consultants to honor an eminent personality from 2010. And coming to today's lecture, today we are having Sri Rajashekhar, who is my close friend, as a speaker. And Rajashekhar is basically an instrumentation engineer who passed this engineering from Mysore University and did his post-graduation in management from ICFA University. His core competences in renewable energy, hybrid energy designs and systems integration, green energy solutions, and power conditioning systems. I know him personally from almost 20 years, and he is very active in this field, and he is known for his knowledge in the renewable energy field. He is a young, energetic, and tech-savvy person. Today we are very happy that he is with us for delivering this lecture on behalf of the Indian Institute of World Culture and audiences gathered together, I welcome Sri Rajashekhar for this endowment lecture, and I request him to deliver the lecture. Thank you, Nana.
Good evening, friends, ladies and gentlemen. Thank you, Prasanna sir. I am honored to be here today in this event. EV technology is a buzzword now across the globe, contemporary subject, and it is this particular contemporary subject this institution has taken as a subject for this lecture, and I am honored to be here to share whatever knowledge that we possess, and I will try to do some justice to this subject today with you. We will proceed now. So, we shall look this EV technology broadly into three parts we will look at. One is the history of this electrical mobility, how it has evolved over a period of time, and the present industry challenges, what is there for its evolution, and what the government policies are, and what we can expect out of this in the near future. So broadly, we have categorized this into these parts. And to coming into the history of this electric vehicles, you might be surprised to know it's there since 19th century. Starting in the early 19th century itself, there has been a lot of interest to replace horse-drawn carriages by electric vehicles. And later, a Scottish inventor during 1930s, he was able to power a carriage drawn out of electricity, but the battery bank was not rechargeable. They had the fixed battery bank, but they were successful in inventing this in the early 1830s. And end of this, around during 1890s, a German entrepreneur, he is credited with inventing a real electric car. He had a company called Flocken Electrowagon, and he was commercially successful in driving a real electric car. And early 20th century, electric cars were quite popular across Europe, and even in Britain, commercial taxis were also being driven out of electricity. But later on, around the 1920s, 1930s, this gasoline-based, IC engine-based electric vehicles were invented. They were quite popular, mainly because the fundamentally electric vehicles had certain challenges. One is the distance. Battery banks, they had not yet evolved to carry for long distances. They had a lot of challenges there, whereas gasoline was a very easy replacement. Electric vehicles and battery technology was very costly there comparatively. So once the gasoline-based vehicles were commercially launched, the electric vehicles went into oblivion. By 1930s, there could be no electrical vehicles seen across Europe. So then the next few decades were completely controlled by gasoline-based, fuel-based vehicles. And again, so this was the first electric car which was invented by Flocken, Mr. Flocken, through his company Flocken Electrowagon. So it might look quite funny, but this is how it was. But whatever, we should credit them with trying something which was revolutionary for that period of time. So again, in the next phase of this EV interest started during the 1970s, mainly because of the spiraling fuel prices. Fuel prices started going very high. And again, the next phase of inventions and the research started for this e-mobility sector. And especially during 1990s, there was, especially in US, lot of government incentives and regulations were made to promote electric vehicles. And between 1990 and 2000, lot of companies, American companies, they successfully launched electric cars. Mainly those times, the electric vehicle means electric cars. Nothing else was conceived, whether it is two-wheelers or buses were not there in the picture. Basically, electric vehicle means electric cars. So General Motors, they were able to successfully launch a lot of cars in US during 1990s. And same time in India also, Scooters India Limited, they were successful in launching a three-wheeler. Commercially, this particular Reva electric cars were there on the roads. But again, later, because due to the lack of proper demand, even Reva also got closed down. Then the next phase in Indian continent, after Reva, there has been no news afterwards. For quite some time, there were no news about the electric cars. Whereas in US, that steadily picked up, especially after the launch of Tesla. In the Silicon Valley revolution, there was a startup, Tesla Motors. They focused very heavily and invested very heavily on electric vehicle technology, and they were highly successful in launching many varieties and a lot of new inventions in the electric mobility segment. And as of now, Tesla controls more than 60% of the market share globally in electric mobility segment. So we can say that Tesla truly dominates this e-mobility segment when we see in the global perspective. And recently, this Reva has been taken over by Mahindra Electric, and Mahindra Electric also has launched so many variants. And Mahindra Electric has the distinction of crossing more than 170 million kilometers through combined fleet of its electric vehicles. Then we can go to the next slide. So let's go through an overview of these EV, electric mobility vehicles. Electric mobility, electrical vehicle, this industry is a multi-dimensional industry. Unlike conventional auto industry, electric vehicle industry needs a lot of vertical support from different stakeholders. Not only there are technical challenges in terms of raw materials, then governmental regulations and the infrastructure to evolve a proper EV user scenario in the country. Now, Indian automotive segment market, right now it is 5th largest in the globe, and it is slated to be 3rd largest in the globe. And India wants to get into this e-mobility segment, which is going to be the next revolution on a large scale. Right now, if we look at the electric vehicle segment in the country, there are around 28 crores total non-electric vehicles, whereas electric vehicles are a little over 13 lakhs. That's about 0.5% of our vehicle population is electric vehicle population. This data is from the central government only. But since the last 2 years, there has been a phenomenal increase in the interest as well as the sales of e-vehicles, mainly because of the push from the government, as well as the interest, general public interest in doing their bit for environment. As per certain reports and the studies done by independent agencies, in the next 5 years' duration, we are likely to touch nearly 1 crore EV vehicles in the country. And in the last, between 2020 and 2021, in the 1 year, we have seen a 168% increase in the sales of EV vehicles. But in this particular 168% sales increase, out of that, 48% is from two-wheeler segment, another 47% is from three-wheeler segment, and car segment is just 4%, whereas buses were a minuscule less than 0.5%. And looking at the entire demography, Uttar Pradesh was the largest contributor of around 20% in the EV market share in the country in the last 1 year, that is 2020-21 calendar year segment. So now, so amongst total, in the last 1 year, not the total vehicles, between 2021, around 1% of the total vehicle sales were from the EV segment. Whereas this is expected to reach around 40% in the next 5 years. That's the target growth that is expected. And with a cumulative annualized compounded annual growth rate, as CAGR, is around 68% is expected in the next 5 years. That means average around 15%, around 12 to 15% it might grow annually over the next 5 years. And that's considered quite a good growth for the EV segment. Right now, if we look at the national scenario, there are over 1,700 charging stations. And this charging stations is expected to be covered by around 1 lakh charging stations in the next 5 years. And this, in the 2021, this industry received an investment of over $6 billion. And this investment is expected to rise to around $20 billion in the next 7 to 8 years. And even venture capitalists, private equity funders are also investing heavily into this emerging sector. And in the last 1 year, we have seen nearly $2 billion investment in this particular sector by private equity and venture VC entrepreneurs. And that's a staggering growth of more than 800% in this particular segment in the 1 year period. And mutual fund companies are also getting directly into this particular segment. And the public can invest in the mutual fund portfolios which are into this green vehicle segment. And Mirai Asset is one company which is having certain portfolios which is investing, where one can invest in the schemes in lithium battery technology as well as EV and autonomous vehicles. And as per Government of India, Ministry of Skill Development, we can expect minimum 10 million direct jobs and around 50 million indirect jobs in the next 7 to 8 years out of EV industry. That's quite a good figures for a job creation. And most importantly, the country can save around $60 billion by fuel imports if we get into large-scale EV usage. That's a very good saving for the country. Now, what are the government pushes in this particular segment? The government has been quite active in the last 2 years, 2-3 years in pushing EV industry. And as per a study on Council on Energy, Environment and Water, it's an independent think tank based in Delhi-based think tank and a Center for Energy Finance. They see an opportunity of $206 billion by 2030. And if steady progress is maintained in India in this particular industry, that's a whopping investment scenario. And actually, that is why everybody is rushing into this particular segment in the country. So, out of this, to create a infrastructure is mainly, one is supply chain industry, second is charging industry. To create this infrastructure, around $180 billion is required to get into the proper charging infrastructure and EV production environment. So the overall situation is that there is going to be a lot of funding, investment government spending on this particular emerging segment, which will certainly create a lot of jobs and also it will spur economic growth. Then India was a signatory to Paris Agreement. Paris Agreement was a UN climate agreement where all the governments basically decided to reduce global warming and reduce the temperature as well as greenhouse emissions every year. So, Conference of Parties, they were called, COP. So, around 192 countries were the signatories to Paris Climate Agreement, wherein they were supposed to come out with the definitive policies for the reduction of greenhouse emissions as well as global warming and climate changes that is happening worldwide. Basically, when you look at these global warming and climate greenhouse emissions, one of the biggest polluters is vehicles. The vehicular pollutions are considered the biggest pollutants, harming the environment as well as the health. Tail emissions of the vehicles, they contain all harmful chemicals, sulfur, carbon dioxide, carbon monoxide, and many other harmful chemicals are emitted by the vehicles, which not only have very adverse impact on the public health, but also on the environment as a whole. So, to mitigate this challenge, EV was considered the ideal solution so that the pollution, mainly vehicular solutions, could be reduced. So, in order to this, under this, again recently there was a COP26 summit in Glasgow, wherein there was a very large push was given by the participating countries, again Conference of Parties it is called, to push EV with a view to minimizing the greenhouse emissions. And after that, India has unveiled a lot of policy initiatives in furthering this particular EV industry. There are two basically broad strategies which are envisaged by the government, central government. Around 1.4 billion US dollars are marked as subsidies. There are two components in these subsidies. One is for the buyers and another is for the manufacturers. Apart from this, there will be tariffs for import components so that domestic manufacturing is likely to be increased because of domestic component. So the tariff will be imposed on foreign imports, and there will be a lot of subsidies for domestic manufacturing. Now, what is the focus of the government in this particular push on EV? One is electrification of public transportation. Every state government is given soft loan or subsidy to buy electric buses. Already in Bangalore, we have seen electric buses already plying on the road. Delhi has been quite vigorous in augmenting its fleet of electric buses. Apart from this, subsidies are offered on all EV segment, be it two-wheelers, three-wheelers, cars, and even buses. Then, for charging infrastructure, government has earmarked 140 million US dollars, quite a whopping budget. So, where government will promote charging infrastructure in oil through their oil marketing companies, that is in petrol bunks, public places, as well as highways and expressways. For this, 140 million US dollars has been earmarked. Apart from that, government also has introduced battery swapping policy. Why battery swapping policy? What is battery swapping policy? Mainly because charging infrastructure cannot be augmented immediately. It can be done over a period of time. So, by battery swapping, and charging takes a lot of time. It may be 30 minutes to it may take 1 day, based on the charging infrastructure and what is the battery bank that is there in the electric vehicles. So, through the battery swapping policy, the government hopes to increase the sales or the interest of the EV buyers, because the basic anxiety the people face while deciding on an EV one is the range anxiety. They may say that my battery will go off and I may not get a charging infrastructure to charge the battery, or I don't have the time to get the batteries charged. So through battery swapping stations, you just dump your battery, take a new battery and go forward. So this is a policy which the government has done, and that is likely to certainly swell the interest of the public in this EV segment. Another government initiative is, there is a public sector arm of the central government called Energy Efficiency Services Limited. They are procuring around 10,000 electric vehicles directly from the manufacturers, and they are planning to distribute to government departments, either on rental basis or directly on sale basis, so that EV utilization, at least in the government segment, goes up. There is another National Electric Mobility Mission Plan, so which again puts a lot of focus on hybrids. Hybrids is something where the vehicle runs both on gasoline, that is the fuel, as well on EV. Hybrids as well as EVs. There is a mission plan component which puts a lot of focus on this. Government has come out with a scheme called FAME, which is faster adoption and manufacturing of hybrid and electric vehicles. So through this scheme, the entire gamut of manufacturing and infrastructure of these electric vehicles is likely to be streamlined and enhanced through this scheme. Already the phase 2 of this FAME scheme is running now, and through this scheme, whatever the incentives, that is the subsidies to the EV buyers are being offered through this scheme only, starting from nearly 2,000 to 1.5 lakhs. Subsidy is offered on various vehicles, be it two-wheeler, three-wheeler, four-wheelers, on buying of these vehicles, again through this scheme. And India launched e-Amrit portal in the COP26, that is Conference of Parties 26 Global Climate Summit in Glasgow. India launched this e-Amrit portal. That's a beautiful portal of the central government. In this particular central government portal, you get the entire information pertaining to the EV infrastructure in India, be it the financing options, investment opportunities, the government policies, what are the subsidies available, and the entire data on public spending on this particular EV industry. Apart from government, the data of exact data, how many EV vehicles are there, and everything. It's a comprehensive portal, and it's beautifully done. And I would request everyone to go through this portal to get an actual idea on what's happening in this EV scenario in our country. And there is going to be an EV super mobile app. It is still in the development stage, but this mobile app is also likely to be streamlined soon, wherein you will get the tariff as well as the charging station information on your mobile itself. Apart from that, government launched the PLI scheme, Production Linked Incentive Scheme. This PLI scheme is basically for the manufacturers, wherein government will provide subsidy based on the production on EV in the EV segment. But here there is a catch, 50% of the components have to be domestic. That is the minimum criteria that is there to avail the subsidy. But the PLI scheme is certainly an encouraging scheme, and approvals have been granted for more than 6,000 EV buses, nearly 3,000 EV charging stations across 25 states. Startups, Arthur Energy, that's already, they are quite popular. And in the passenger vehicles, that is car segment, Tata is leading. Tata it's a well-known name now in EV segment. Mahindra has unveiled 5 models recently, and they are going quite aggressively in this particular segment. They already bought Reva, and they are likely to be quite aggressive. And apart from this, most of the top names, the international names, they have lined up EV facilities for Indian market as well. What are the other major industry challenges that is faced? Now, when we look at the EV, electric vehicles, typically, when we differentiate EV from the conventional vehicles are powered by gasolines, which are combustion engines, which is quite popular and already that is tested. In electric vehicles, the most important parameter or part of an electric vehicle is the battery. That is, the storage is the most important mechanism for any successful running of electric vehicle. So here, the battery part is lithium-ion batteries are used in any electric vehicle. And the cost of the battery is almost 50% of the vehicle cost. So that is which is quite expensive. So what are the why it is so? Because it is lithium-ion batteries, and lithium mineral is not, it's very scarce in India, and we cannot commercially exploit lithium mineral in India, and we are dependent heavily on imports, lithium. So for the lithium-ion basic ingredients, lithium, cobalt, nickel, all these ingredients, minerals are imported. So because of this very high import cost, electric EV segment is one of the driving factors for costly EV market scenario. And looking at the world scenario, EV is also not uniformly distributed among the global countries. Bolivia has about 40% of world's lithium deposits, Latin American country. Even Russia and China also have huge deposits. So India is heavily dependent on import of this particular mineral, which that is the raw material. And after that, this raw material, once it comes, it has to be manufactured into a battery, as a battery, which will form the basic fundamental part for an e-mobility vehicle. So here there are a lot of technical challenges. It's like unlike a conventional energy storage systems, vehicle batteries, lithium batteries, they are highly flammable, and they are highly temperature sensitive. So you need to have a proper battery management system. Otherwise, any manufacturing defect or any increase in temperature beyond the battery point will trigger a fire from the battery. So because of this, in the last 2 years, quite a lot of battery-related fires were reported from the industry, and central government has been investigating each and every reported incident of battery fire, from whether it is a two-wheeler or any other vehicle. So central government has come out with a policy guideline, stringent policy guideline on lithium-ion electric vehicle battery manufacturing guidelines, which is likely to stabilize this particular market. But mineral procurement is one thing, then production of the batteries is the next stage. So then comes the quality EV battery manufacturing. That is where the entire quality of our electric vehicle rests on battery. So quality EV battery manufacturing has to be promoted. Government is actively involved with the industry and stakeholders in this particular segment, and still we are in a very nascent stage, and it is likely to be stabilized in the years to come. And next, charging infrastructure. So charging infrastructure, right now it is highly inadequate, because of which people are hesitant to go into electric vehicle segment. So that is why, as we have seen in the previous slides, government is investing heavily on promoting the charging infrastructure across the country, and that is where the whole EV policy hinges on that. Then reduction in cost. Now, because of the very high import costs involved in battery segment, the costs of the EV vehicles are pretty high. If you look at car scenario, average car prices are around 13 lakhs, EV cars. Recently, Mahindra has launched, Mahindra or Tata, one of these companies, they have launched an 8.5 lakh EV car very recently. But in general, it ranges above 13 lakhs. So that is a price barrier. So because of that is one price barrier, unless the supply chain difficulties are addressed and import costs are reduced, this price barrier cannot be mitigated, and unless price barrier is not mitigated, the car segment may not see high sales. But certainly there has been quite a push in three-wheeler segment and two-wheeler segment. Starting from 30,000 to 1.5 lakhs, we are getting e-scooters, and three-wheelers have been quite a hit in especially delivery, short-term in the city delivery mobility solutions. And that particular segment is likely to see a big percentage volume increase in the years to come. And buses, because of the central government intervention and the state government interventions, they are also likely to see quite a lot of incremental volumes. But car volumes, which is at the moment, which is around 4%, to see a huge increase in this particular sales, maybe the import barriers or the cost barriers may have to be addressed. So these are some of the major challenges that we see in this segment. And apart from that, what are the end user challenges that we see? Typically what we see is one is range anxiety. Range anxiety is how long I will be able to go after one charge. That is the basic range anxiety, which can be addressed through proper charging infrastructure. What is time anxiety? Time anxiety is once your battery goes dead, how long will it take for the battery to get recharged so that I can continue my journey? So this is the time anxiety. To address this, government has come out with battery swapping policy. Then charge anxiety, it is similar to this range anxiety, that is whether I will find a charging station or not. So the first and the last can be addressed through proper charging infrastructure, and the second can be addressed through swapping of the batteries. And next what we have is other challenges. Now already you would have observed a lot of charging stations in our oil petrol stations, especially Indian Oil petrol bunks. They are having EV charging stations, and some of the few of the private such as this Nayara also has come out with a lot of electric EV charging stations in their fuel outlets. But the problem associated with this is high initial investment to set up a charging infrastructure, whereas there are no customers. Hardly they get 2 to 3 customers in a day, which is hardly 10 to 15% utilization of their charging infrastructure. So there is no break even. Commercially, it is considered unviable. So that is the reason government intervention is required to set up the charging infrastructure, because private charging points at the moment doesn't look viable unless the sales of EV vehicles pick up across all regions. Then there is a FAME 2 policy which states that if you have to put up a charge station in a highway, it has to be a minimum 100 kilowatt charging station. To put up a 100 kilowatt charging station, you require an HT infrastructure. Normally say, let us say in Karnataka, up to 50 kilowatt it is goes in LT, and above 50 it is HT. And I have a small outlet, let us say in a highway, and if I have to put a 100 kilowatt, then I have to take an HT connection. Automatically your initial investment and your fixed charges go up. That means both your recurring cost as well as your infrastructure investment cost goes up. So this is another deterrent for small players to set up charging infrastructure across the highways. So whereas only in Delhi, this is up to 100 kilowatt, it runs on LT. So in Delhi already we can see a lot of private operators putting up charging stations across highways. Third, another thing what we see is basically what the manufacturing industries they face is lack of trained manpower in this. See, EV hybrid vehicles and EV vehicles, it's a specialty field. The manufacturing segment in this particular industry, they require skilled manpower, which India is not possessing hugely. So this is one roadblock, maybe which only over a period of time only this can be overcome. Right now, the industry is facing manpower issues. Maybe the existing technicians only, they may have to be retrained to cater to the manufacturing industry's requirements. Then another issue, that is the uncertain consumer behavior. because of all these issues associated with the charging infrastructure, pricing barrier, or other anxieties, consumer behavior is highly uncertain. It is very difficult to exactly get into a roadmap wherein, yes, tomorrow there will be 10% growth, and or maybe the company, whoever wants to invest in this, if they want to sell, say, 1 lakh units, they are not certain. So uncertain consumer behavior, it is a barrier for a lot of investors to hugely invest in this segment. Unless who are already associated in this particular automotive industry, mainly the startup investments are not fully coming up, mainly because of the consumer uncertainty or the consumer behavior buying patterns. Then another, as I have already mentioned, the price barrier. Little EV vehicles are certainly costing higher, which initial entry costing barrier, people always, India is highly a sensitive market when it comes to pricing. So people always think twice if the cost is high. There is always a barrier to the consumer sentiments.
One thing is 8.5 lakhs, he says, Tata.
Huh.
You don't get it.
They have recently launched.
They have recently launched for only the booking. You don't have the display of the vehicle anywhere in Bangalore.
Huh.
I don't think that it is available in Pan across, but 8.5 lakh is only the basic vehicle.
Yes.
Without any.
Correct. Basic model.
Yeah, it's a basic model. It goes up to 11.5.
Yes. Always entry level models, but
That too, it is a hatchback car.
yes, it is a hatchback. Yes. It is a hatchback only with a sticker price. That's why I have mentioned it's a sticker price, because still we don't know. Exactly on-road price could be what, we don't know. That's why it's a sticker price. But on an average, those established brands, average pricing is starting from 13 lakhs, which is established cars. Then we are already having supply chain problems, as mentioned already. The manufacturers are already having supply chain problems, because of which it's a major company, both from the investment side.
Mahindra is having 13 lakhs, the basic.
Yes.
But they have given all the infrastructure, everything.
Yes. That is, see, it is a nascent stage yet. Lot of things are coming, lot of things are evolving. What I say today or what we see today might be totally different after 3 months, because things are, it's dynamic. So a lot of things are happening, a lot of things are evolving in this industry. So it is a dynamic evolution. So what we think of now, what we say now may not be there after 6 months. There could be a lot of improvements also. But we expect a better perspective over a period of time. Let's see. So then another impact that is from the investment perspective is this in the FAME 2 policy, which requires 50% localization component in vehicle production. But right now what's happening is that is an entry barrier for a lot of investors, because it is difficult to make 50% localization at the moment because of lack of volumes. So all the components are not being manufactured here, or localization is not easy to get into 50% of localization in the EV production scenario. That is why the production-linked incentive which has been offered through the same 2 policy, it may not be easy for the manufacturers to avail, considering this 50% localization in production barrier. But however, government is justified in saying so, because that is the only way where they can push the Make in India concept. But it has both the sides of ramifications. Then another issue that we foresee is serviceabilities. EV vehicles, they require specialized technicians. It is not like conventional IC engines where any roadside mechanic can service the faults. Even though the major car makers, they say that yes, they will give support across every service centers of theirs. Still, as far as we see, the technicians which are already there in their showroom service centers, they are not equipped to handle EV cars. So, considering if there is a breakdown, it may not be easy for the consumer to fix it. Unlike our conventional cars, which we can drive without any tensions connected to serviceability. But these things are certainly going to be improved, because if a car maker releases his car, he has to have the service, chain in operation. But these are all temporary issues which we are facing at the moment. Then why electric cars? Why so much of buzz around electric cars, apart from the environmental impact that we have already spoken about? The basic, from the perspective of consumer, the most important factor which is driving the EV segment is the cost, running cost and maintenance cost. The running cost for an EV vehicle, considering I'm generally taking a car as the benchmark here. It will vary for two-wheelers and three-wheelers. Two-wheelers, I think it's around 20 paisa to 50 paisa per kilometer. For cars, it is around 1.2 to 1.5 kilometers. Whereas same thing, for a petrol car, it may range anything from 6 rupees to 10 rupees per kilometer car, based on its mileage and other things. So economics makes EV vehicles are quite a hit. And secondly, the maintenance cost. Since there are not much of moving parts in an EV vehicle, the maintenance cost drastically reduces. You don't have to, change your oils, and it is considered to be quite reliable, and accordingly the maintenance cost is supposed to come down. Then anyway, we do have this savings on CO2 emissions, that is how much greenhouse emissions we can save by switching into electric mobility. According to the estimates, by 2030, India can save around 1 gigatons of carbon dioxide emissions if we go as per the projected numbers of electric vehicles in the country. And for general public, if electric vehicles are more, certainly we can see lesser smog, we can certainly see lesser pollution. And because there's a zero tailspin emission from electric vehicles, that is the direct advantage as a general public can see. Another thing is, these are gearless vehicles. So we have certainly driving experience is considered to be quite smooth and incredible, which will reduce stress and fatigue. That is another advantage that the EV vehicles are offering. And finally, there are tax benefits. You can certainly, apart from the subsidies, you can claim tax benefits. If you are a business owner, you can claim accelerated depreciation, 40% accelerated depreciation benefit in the very first year, if the vehicle is registered in the company's name. Apart from that, there will be, if you are taking loans, around 1.5 lakh, up to 1.5 lakh rupees benefits, subsidy benefits on interest are also there. There are many such policy interventions with regard to the benefits offered, both in terms of the tax as well as in terms of the loans by the central government. The exact details of all these things are available in eAmrit portal. Typically, this is a general table, charging times of the cars, EV electric vehicle. How do we determine what is the charging time for my vehicle? So basically, we need to know what is the battery bank that the particular vehicle is having. For two-wheelers, it could be anything from 250 watt-hours to 4 kilowatt-hours. Electric scooters, starting on the basic models like small cycle-type e-scooters, it may be having a small battery bank of 250 watt-hours. Very high-end electric scooters are having 3 to 4 kilowatt-hours of battery banks, whereas cars, they have battery banks ranging from 18 kilowatt-hours up to 100 kilowatt-hours. Typically, if you are looking at hatchbacks and sedans, they have around 36 kilowatt-hours up to 40 kilowatt-hours battery banks are there. That is one part. Second part, and what is the charging infrastructure that you have? Suppose you have a 3 kilowatt of charging station and your battery bank is 18 kilowatt-hours. You will require 6 hours to charge your battery bank fully. So both are correlated. What is your charging infrastructure? What is the capacity of your charger? And what is the capacity of your battery bank? These two, based on these two, you know exactly what is the charging time that is required to fully charge your battery. So typically it can be anything from 30 minutes to it can take up to a day also. So here certain infrastructure bottlenecks that what we can see is, suppose you are having a high-end car, so let us say, or maybe let us say a 40 kilowatt hour battery bank car, and you have a charging infrastructure. Your contract demand itself is 3 kilowatt, and you will not be able to put up a very high current drawing charging infrastructure, and certainly it will take more than 10-12 hours to charge your car once it is fully discharged, for a full charging after a full discharge. So these are all certain bottlenecks. Another thing is, if you are in an apartment scenario where multiple houses are there, again, the charging infrastructure, putting up a charging infrastructure may not be easy unless all the householders, the homeowners association, they come into an understanding. And again, that is a bottleneck. And that is why the charging scenario is yet to, infrastructure scenario is, it is still yet to evolve properly. Then, these are all, we have seen multi-dimensional benefits and all the related aspects of this particular EV, electric mobilities industry. But there are a lot of other concerns and questions which are raised on e-mobility push by all governments across the globe. What is the basic question? Some of the most important concerns and questions that's being asked in this particular segment is, one is production of the battery. So production of the battery requires mining. Lithium is a mineral, and you need to mine this. Lithium, cobalt, nickel, all these they come out of the mining operations only. So mining operations is certainly a hazard. Mining operation is an environmental hazard. Mining operation is also, they use all fuel-based equipments and vehicles to carry out these operations. So you are using the minerals which are being excavated or extracted using highly polluting means. And to what extent you are saying that the EV vehicles are environmental friendly? This is the basic question that is being asked, and to a certain extent it is true also. Then, this is what mining has huge environmental impact, mainly using fossil fuels and toxic minerals. What happens is the mining, in the process of mining, it can release a lot of toxicity into the environment, resulting in acid rains and other environmental impacts. Then, most important factor which we are concerned about is the charging. I have an electric vehicle and I require 30 units or 30 kilowatt hours to charge my electric vehicle, and I utilize my grid to charge this particular electric vehicle. That is, I draw 30 units. This 30 units from the grid, if it is produced from fossil fuels such as coal, where is the environmental benefit? So coal, again, it is an environmental hazard. Coal plants, they are considered highly polluting, and coal mines are also considered highly polluting. So, in countries or in regions where the charging infrastructure is mainly driven from energy which is produced out of fossil fuels, then where is the environmental benefits that we claim to have? This is the fundamental question, and this question I personally feel is valid. So, what is the solution for this? Solution is to have renewable energy sources to charge this charging infrastructure. Suppose you have a car which requires 35 units to charge, then you need to put up a 10 kilowatt of solar to deliver that amount of energy which is from the non-conventional renewable energy. So that means to say that you are spending a 15 lakhs on the EV vehicle and put up a solar power plant of 10 kilowatt, you are investing another 6-7 lakhs rupees. So the initial cost of investment is pretty high unless you are truly environmental conscious to mitigate the carbon emissions, and you are affluent enough, or you have, if it is affordable to you, people will not be able to go for it. As of now, the sales are being driven by two-wheeler segment, three-wheeler segment, and we don't see this particular impact. But if we look at charging of the buses and charging of the cars, which require huge electricity, then the so-called environmental benefits that we claim to have by using EV vehicles, they are completely negated by if we use grid infrastructure, that is, which is powered from fossil fuels. Apart from this, accumulated charging stations in a particular substation or a grid station can result in grid imbalance, and we have our experts from utility here, which I think they should certainly agree with me, that huge charging infrastructure without planning, without understanding what is the infrastructure that is available from the utility in that particular transformer or TC will result in grid imbalance, and this is going to be a major bottleneck if the stakeholders, without studying these aspects, if they indiscriminately go into putting up charging stations. That is another aspect. And apart from this grid imbalance and charging from the fossil fuels, we also have another issue is the safety issue, which is from the lithium-ion batteries, which are highly flammable. So in case of a collision, the charges of fire are quite high. In case of battery manufacturing defect also, temperature, if the engine, see basically what is happening is, what should happen is ideally, there is a battery management system associated with the battery pack. So this battery management system is a software-driven electronic functionality, which will continuously sense the temperature and other discharge parameters and other parameters of the battery. And in case it senses any variations in the parameters, and mainly temperature, it has to automatically switch off the, cut off the supply, that is the electricity discharging path from the battery to the vehicle, and the vehicle has to stop. But in case the BMS, the battery managing system, or the production side, if there is a technical glitch, that is, if this production process is not foolproof, there is a possibility of fire hazard.
Even people may die.
Yes, people may die. So people have already died also. That is, government is investigating each and every case. In fact, through the ministry has directed that every reported case has to be, investigated. So now, government very recently, it has come out with a set of very stringent guidelines for lithium-ion battery manufacturers.
Whereas in internal combustion engines with airbags, they are more safer.
Yes.
Than this.
Yes. See, typically in a collision, the collision impact is something which we have to be worried about, and airbags to a certain extent, they protect the occupants. But here, in a collision in an EV vehicle, apart from the collision impact, you have issue with regard to the fire also. So this is something which needs to be, of course, addressed. Typically, if we are looking at city mobility, then this particular situation doesn't arise, because normally even if a collision happens in a city environment, the impact wouldn't be so high to result in a fire, whereas in highway and expressway scenarios, this is a real danger. And certainly the stakeholders are working on the concepts to see that the EV vehicles are quite safe. And government has come out with very stringent guidelines recently, and these guidelines are applicable for all the batteries which are being rolled out after December, to see that the BMS and the entire battery manufacturing cycle, entire production cycle, it conforms to the standards of the guideline. And hopefully we should be able to see a lot of better results because of this government intervention in this. And Another thing is huge cost of the battery replacement. 50% of the total cost of the electric vehicle is the battery. So, certainly, this is going to be a deterrent when you look at buying an electric vehicle. Suppose 13 lakhs is the cost of the battery. If you are spending 6.5 lakhs on replacing the battery, then that is something which every consumer will ponder over. So mainly that is because of the high import cost. So, but what do they batteries? What is the warranty and the life that the batteries are that we can expect? Typically, the warranties that is being offered, that is for the cars, is they say 1,60,000 kilometers of life or 8 years of life, whichever is earlier. So if you drive up to 1,60,000 kilometers, your warranty expires. Or if you don't drive much, till 8 years you have the warranty support for the battery. The battery manufacturers claim that the battery life would be up to 15-20 years, but we don't have the data how long these batteries will last. So only the time can tell about these things. But as of now, typically if you say daily if you are using your car for 100 kilometers, then you will need to replace your battery in roughly around 5 years of time. So if you are having a 15 lakh car, then you should be ready to shell out around 7.5 lakh rupees after 5 years. That's roughly around 1.25 lakhs per annum, which is your battery replacement cost. So this is another challenge which needs to be overcome. How we can overcome this particular aspect is, as of now, why the battery costs are pretty high, mainly because of the minerals which are being imported. There is another field through which the battery costs are likely to come down. That is what is called circular or urban mining or recirculation of the batteries, these lithium batteries. That is, the batteries after their end of life, which is around 70 to 80% of their life, we consider them end of life. So once they come back into the OEM, these batteries are recycled and minerals are extracted. This is what is called urban mining, because the minerals we are able to extract it in the city itself. We don't have to go to the mining site, polluting the environment to extract these minerals. So through a concept of urban mining, that is what is called circular industry, we say. It's nothing but recirculation of the batteries, and the concept of urban mining, we will be able to get the raw material, the mineral, through which will be quite cost effective. There is no import component, and we can use the same minerals to produce the new batteries. So this is another concept, but as of now, we will not have batteries coming back. This will happen after 5 or 6 years, wherein after their end of life, maybe after 5-6 years, we will get sufficient batteries which will come out back into the system out of their warranty period or after their end of life, so that they can be the companies can recycle it, and maybe the import costs may come down. So urban mining is a concept which may reduce the battery cost, which in turn may reduce the total cost of the electric vehicles. So what do we finally conclude? Certainly, e-mobility is a game changer. When we look at consumer interest, when we look at stakeholder interest, government interest, or general perspective to reduce the greenhouse emissions, certainly EV is a game changer, because what we as a normal layman, what I see is choking roads due to pollutions. In Bangalore, we have still not seen to that extent, but Delhi, yes. Delhi, yes. Even Hyderabad and certain UP cities also, I have seen terrible vehicular pollutions where we feel choked after living here in Bangalore. And when we see from that perspective, roads having green vehicles, electric vehicles, certainly might make the life of the citizens, common citizens, easier because of lesser noise and lesser pollution, and for government also, it is the easiest way to adhere to the Paris Agreement, where they can say that we have switched to e-mobility and we have saved so many tons of CO2 emissions, and we have adhered to the protocol, that is the Paris Agreement and COP26 agreements. So that is why governments are investing, business houses are investing, consumers, those who can afford, are also certainly showing a lot of interest, and certainly the smaller range, such as in two-wheelers and three-wheelers also, we can see a lot of interest because of mainly the saving and easy loans that is being given. Even there is a mandate from the RBI to see that the public finances, that is lending loans to EV vehicles, is on priority sector lending. So certainly it is going to be a game changer, and as I have mentioned, extracting critical minerals can certainly cut the imports, and also it will aid sustainability in the long run. Large-scale utilization of renewable energy for charging infrastructure through whether it is solar, wind, or any hybrid energy sources will certainly mitigate our concerns on using fossil fuel-driven electricity to charge the batteries, and certainly it will aid our climate change concerns and aid sustainability. And finally, the new battery safety norms would certainly allay the fears of the consumers on many safety and fire-related fears, and hopefully public will put their hearts into this. And I would say that EV mobility, electric vehicles and e-mobility is going to be the next in the infrastructure, that is automotive segment and infrastructure transportation, especially urban transportation segment. That's going to be the next future. And we can certainly see a lot of developments in the future in this particular segment. And I hope I have covered many aspects in this particular EV segment, which is quite exhaustive. In fact, this segment is quite nascent, and we are not still very sure about so many aspects. And this platform is not, or the time is not, it's very short to go deep, dwell into that. But I hope I have done some justice to this particular talk, and I am certainly honored to be here, and I thank all the members of the Indian Institute of Agriculture for giving me an opportunity to talk and share whatever knowledge, little knowledge that I possess in this subject, to present it before you. And I conclude with this. Thank you very much.
Yeah, solar vehicles.
Huh.
Better than this electric vehicle. Solar, it can be replaced.
Solar?
Solar vehicles. Solar vehicles.
Huh.
So actually in one of the countries, I don't know which country, they have a road where charging by solar is there.
Yes.
So no time is wasted. And
Agreed.
it is cheaper than your...
Sir, here what happens is, certainly that is an option that can be considered. Sir, is a renewable energy charging basically. Agreed. But there are sort of a lot of challenges in providing you a renewable energy charging source across the road. Very difficult. Okay, because as you have put out, continuously it can be charged. That is, practically it is not easy unless you have a stretch wherein for kilometers together where you can have like an electric train where you can have a link to charge. It is very difficult to be implemented in India because of basically the geography may not permit for us to do that, even though it is feasible, theoretically feasible. Second, we cannot adopt solar panels on a vehicle because the surface area that we have is very less to have a meaningful charging of the battery when it is moving. So hardly we can have 1.5, 2 kilowatts on a bus also, and which will, no way it will charge the huge battery bank of the bus. And putting up panels on the car is, aesthetically it is not feasible and not practical also. That is why we have limitations to have a mobile solar powered vehicle. Whereas it is certainly feasible for us to go for a renewable energy powered infrastructure. That is a fixed infrastructure, that is the EV charging infrastructure, which is powered from a renewable energy source. So that is very much feasible. But at the moment, I personally feel that mobile powered, renewable energy powered vehicles to charge your battery bank on the move may not be feasible as yet in our country. That's my.
So I have a question. We keep hearing about lithium battery being 100% used for electric vehicles now, and Reliance is investing billions of dollars for sodium, and one other company, some other
Hydrogen.
So what is your take, and where are we right now?
Certainly, sir. That is what. See, under the government FAME 2 policy, so that is faster adoption and manufacturing of electric vehicles and hybrid vehicles. That is the FAME 2 policy. So there is a production linked incentive. So production linked incentive is a huge. Thousands of crores are being given by the central government as production linked incentive. To avail this production linked incentive, you need to have 50% localization. How can you have 50% localization unless you are able to invest millions of dollars? It's impossible. That is why the companies, in the likes of Reliance, they are able to do that. A small scale or a medium scale segment industry may not be able to, invest so much of funds, millions of dollars of funds to avail the government incentive. Point number one. Point number two, EV is going to be the future in electric mobility. Governments are hugely funding that. So any person, any corporate entity, they would like to have their footprint in a segment which is considered as future. So EV is going to be the future in terms of urban mobility or transportation segment. Certainly, I don't think I think Reliance or any major, for that matter, any major corporate will certainly try to put their shoes in this particular segment.
But what is the feasibility of using sodium for battery? Is there any, it's hype or like?
So, are you talking about hydrogen, sir?
Sodium.
As of now, sodium powered batteries, we are not aware about that. But there are certainly hydrogen powered fuel cells, which is, and government is heavily investing on hydrogen fuel cells, which is considered green and more greener rather. We don't have all these concerns and challenges when we say it is hydrogen powered vehicle. Already hydrogen, green hydrogen, what we say. See, from the water, basically what is green hydrogen? They take out hydrogen and oxygen. See, water is nothing but a combination of hydrogen and oxygen, H2O. So, they have a electrolysis process where they separate hydrogen and oxygen. So, this hydrogen is used as a fuel cell to power the vehicles. Already since last many decades, hydrogen fuel cells are being used to power airships, satellites, even fuel, even.
Which vehicles it is used hydrogen? Is it in IC engines?
See, hydrogen, it is similar to our electric vehicle, battery powered electric vehicles. The hydrogen powered vehicle is a separate design topology. You have a hydrogen, like our fuel tank, you have a hydrogen tank. And you can refill your fuel tank, like your fuel tank, you can refill your hydrogen from the hydrogen tank. Why it is, see, there are hydrogen fuels and green hydrogen fuels. It is qualified as a green hydrogen fuel provided you are able to derive this hydrogen using green methods. That is, you need power for this electrolysis process of the plant, hydrogen plant. You need power. It's a plant to differentiate this oxygen and hydrogen. You need power. So if this power is derived from renewable energy plant, using solar or wind or whatever, then that qualifies as a green hydrogen. So using that as a green hydrogen, if you are running your car or any other vehicle, then you can say that certainly you are driving a green vehicle. But the challenges here is green hydrogen vehicles. One is shipment. It has to be highly in a condensed form, and shipping the hydrogen tanks are not that easy. So hydrogen tanks are not that easy for a large, to have huge infrastructure wherein just like we go into a petrol pump and buy our fuels, it will not be that easy to get the hydrogen fuels in the near future. Typically, per kg of hydrogen, it's about 500 rupees. And you can run about 80 to 100 rupees, 100 kilometers per kg of hydrogen fuel. So roughly it is equivalent to our fuel cost only. Our petrol cost only, it is almost at par. But making a hydrogen electrolysis, no, it's 100% pollution free. We don't have any of these concerns or environmental impact. Hydrogen, that is why government is investing on hydrogen energy as well.
Power and L&T and other company have joined to produce this H2O hydrogen.
In Ladakh, there is a 500 megawatt green hydrogen plant is coming up in Ladakh, which is powered 100% from solar energy. NTPC is building that. And
Hello, yeah. This hydrogen cell concept is well researched in Toyota. Since I'm into green energy and I run my company. Operation cost wise, it is the least actually.
yes,
To run 100 kilometers, what I understood is around 12 rupees or 13 rupees at that cost, operation cost, what I'm telling, the investment cost. So they have run the vehicle in R&D in Toyota. But to come to market, it will take, of course, minimum 5 to 6
because
years.
right now everything is in prototype stage.
Sir, already has been given one vehicle to Nitin.
Yes, Nitin Gadkari has started hydrogen fuel vehicle.
Now it is trial and error is going on.
Yeah, it's going on.
Correct. See, it's based the cost that dynamics that I have said. These are all the initial costs which is happening in the industry. Yeah, because see, basically you need to invest on a plant for electrolysis, and you need to invest on a solar or any other renewable energy plant to power it. So it is a huge investment. So initial investment is pretty high to get the green hydrogen fuel for us. That's why the cost of the hydrogen is a little high now, as of now. But everything, as we say, it is all economies of scale. And as the technology improves and as the volumes go up, certainly they also may become the future fuel. Everything has time only can answer.
So it may become future vehicle
Yes, it may become, yes. Certainly it may become future, yes.
than the electric.
Yes, possible. So right now, government is giving lot of fillip to even green hydrogen fuel facilities also.
Hydrogen is also coming at Rajasthan. Recently,
Yes, government is giving a lot of importance for green hydrogen as well.
We are also, promoting, electric vehicle charging systems actually. I have already implemented in, a mall in Magdi Road.
Okay.
GT Mall.
Okay.
Already installed actually. Where this is actually 3.3 kilowatt system, which comes with the cost of around 14,000 rupees. It is actually 17,000, but company is giving discount, so we are also passing it. Around 14,000 rupees, you will get 3.3 kilowatt. For cars, it requires around 4.5 hours. For two-wheeler, it is around 2.5 hours or 3 hours.
Again, it depends on what the battery bank the car has.
Battery bank, yeah.
Yes.
Yeah.
For a typical small car, around 15 to 18 kilowatt hours of battery bank, it will take, as you said, it will take around 4.5 hours.
We approached apartments also. The thing is, they are not ready to pay even 14,000 also.
That's mainly because of the utilization rate, sir.
Yeah.
Hardly 2-3 vehicles they come in a day. And for even they think that by paying for 14,000 rupees, it will not come back in 10 years, they think as of now. Because, no vehicles are coming.
I think swapping is the best.
Swapping is is a better area. That is why government is coming out with that option. See, right now, you don't have EV vehicle penetration in the market.
Charging around
Yes.
25 rupees per
Yes.
kilowatt.
Yes, correct.
So
Yes.
that will work out for
That will work out actually.
malls.
See,
It will work out.
sir, right now what has happened is EV segment, if it comes to passenger vehicles or four-wheeler segment, it is considered an upper class, mobility option because of the cost involved. Whereas the two-wheelers and three-wheelers, it is in the common, it has already penetrated the common, general public segment.
And I heard this logistic vehicles, especially as you said, autos and three-wheelers and logistics, electric vehicles, they are actually finding very difficult for charging infrastructure actually.
Yes.
So that way demand is also there, but proper infrastructure is not there.
Yes.
Even though charging systems are there, somewhere we are having the lacuna.
Correct. See, in many houses, it may not be easy for them to get an outlet socket segment in India.
Basically, what is experienced is we approached colleges also, medical college, engineering college, and they are not taking interest. See, students are charging actually. It should be a revenue point for the college to charge for them actually.
Sir, basically the information has to go down in every strata of society. These things, the people should be made aware of the policies, the challenges, and the solutions. Then only this concept of EV concept can be popularized. So, luckily we have this institution which has come forward to at least arrange something on this. Similarly, the institutions, the educational institutions and other public institutions should certainly come out and arrange. That's what government is already, it has initiated this.
Lithium ion battery is the only criteria. Is there any other?
Right now, lithium ion is considered the only storage solution for electric vehicles, sir, because of its longevity and relatively stable weight for discharging in the automotive segment.
Space is quite
Less.
compared to.
No, actually, if you look at the conventional lead-acid batteries, the space is less for a lithium-ion battery bank.
Earlier, that two-wheeler came with lead acid battery only.
Correct.
I think you people are don't
Correct.
know, I don't know. But Electro Anil bike was first, it came inaugurated by Gundurao, Chief Minister.
Even, sir, that India Scooters Limited, the electric vehicle, it was with not with lithium batteries. They are with conventional batteries.
Question and answer, but it is a failure. We can discuss with them after 2-3 years.
Maybe if anybody has any,
I think we can continue this discussion definitely
After the program also.
after the program.
they have any
Today, thank you, Rajashekhar, for your very much enlightening lecture. And it has created a lot of interest among the participants. And if I want to tell, we are in the transition period from the petrol vehicles or diesel vehicles to electric vehicles. And the technology is not fully matured yet. It is maturing. And as we know, the petrol and diesel vehicles, still some R&D is going on. It may be from last 100 years. But whereas the EV vehicles, maximum may be around fully dynamic environment has created just from last 20 years, I hope. That's why it is taking time, and it may evolve or mature within another 10 years, I hope. Why government is pushing so much? It is very clear. Every year government is, our foreign exchange, we are spending around 16 to 17 lakh crores for import of oil. Government wants to save that so that it can be used for the developmental activities within India. That's why government is putting so much pressure or push to develop the EV industry. And at the same time, government is also thinking to avoid this, save this foreign exchange, especially this foreign exchange, and Atmanirbhar Bharat. And the main distinct points only, if I want to mention, technology, as I told, it is not yet mature. The major this thing is with battery. Battery, there are a few more points. One is the battery weight, then battery age. Then once again, we are depending for the lithium, we have to import. Therefore, import content is more. And there are so many environmental activists, they are opposing battery industry because of the mining hazardous or pollution created in the mines while extracting the lithium. And as our secretary mentioned, sodium-ion batteries, Reliance is putting a lot of efforts in developing the sodium-ion batteries, but once again, it is in the R&D stage. And major negative points in the charging stations, one is, as he said, volume of the power required at the charging stations. Not only the power requirement, it is the space requirement. Even in a 30-40 site, they will put a petrol station, petrol bunker, you know very well. But for a battery charging station, since it takes a lot of time for charging the units, it requires a lot of space. Space is also a major concern in the urban area. Half an acre is required. In the urban area, it's a very big challenge. And and another point, we have to think about the disposable of old batteries. That system is also not fully evolved. He has mentioned a very good point that urban recycling, that one. And I was discussing with one of my friends, there is a concept of mobile charging units. They will come with the mobile van and they will charge your vehicle at your place. Suppose if Rajashekhar goes to a office, there he finds that the charge is going to be not sufficient to go back home. At that time, he can call. The people will come with the mobile charging unit with their own battery setup. With their battery bank, they will transfer the power. This is also a concept. It is not yet practically this thing. No, I discussed with that. He said they may charge around 7 to 10 rupees per kilowatt. It is this thing. Therefore, there are so many this thing. At the same time, a lot of R&D activities are going on in the battery industry. And another positive point compared to 200 years back, when it was an astonishing point that electric vehicles came much more earlier than the petrol vehicles. Really, when I saw that slide, I was really astonished.
No, nobody knows that.
Nobody knows that. Nobody knows that. It is a
Say thanks to
Rajashekhar for highlighting that point. Another point is now software has matured a lot. Therefore, the software also can contribute to a lot to the EV industry, especially in the managing the battery. Especially managing the battery and avoiding the fire issues. Therefore, ultimately, now we are in a fix. We have to come out of this dependency on oil. That's why we have to go to the EV industry. Already two-wheelers have picked up. I am using my electric vehicle from electric scooter from last 2 years without any problem. Therefore, only thing is heavy vehicles only the issue now. Slowly it will mature. As Rajashekhar mentioned it, it may take another 5-10 years to completely mature. By that time, even hydrogen vehicles also may come. ಕನ್ನಡದಲ್ಲಿ ಗಾದೆ ಹೇಳ್ತಾರೆ, ಹುಚ್ಚು ಬಿಡೋವರೆಗೂ ಮದುವೆ ಆಗಲ್ಲ, ಮದುವೆ ಆಗೋವರೆಗೂ ಹುಚ್ಚು ಬಿಡಲ್ಲ ಅಂತ. ವಾಲ್ಯೂಮ್ ಇನ್ಕ್ರೀಸ್ ಆಗೋವರೆಗೂ ಪ್ರೈಸ್ ಕಮ್ಮಿ ಆಗಲ್ಲ. ಪ್ರೈಸ್ ಕಮ್ಮಿ ಆಗೋವರೆಗೂ ವಾಲ್ಯೂಮ್ ಇನ್ಕ್ರೀಸ್ ಆಗಲ್ಲ. ಹಾಗಾಗಿ ವಿ ಆರ್ ಇನ್ ದಟ್ ಸಿಚುವೇಶನ್ನು. ಇಟ್ ಈಸ್ ವೆರಿ welcoming issue. So many participants participated, especially the people with a lot of curiosity and interest. You have participated in this program. I think really it's a very good program we conducted, especially on the technical issue. For the normally other issues, coming people attending the program is not a big issue. Especially a technical issue like this, a well-attended program, I feel. And I once again thank the audience as well as the Rajashekhar for delivering this very good lecture and making this lecture very good, this thing. And I think it is a very, I know Sri B.J. Rudrappa, sir, who was the chairman of the KEB, and I think his soul will be very happy about this lecture. People are voting for it. I am very happy, and I request our Honorary Secretary Venkatesh Prasad to honor our speaker.
Thanks to you people to identify Mr. Rajashekhar to present this.
Venkatesh. Once again, thank you one and all for attending this lecture and making it a successful program. Thank you.